Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh, and a very good morning to all presenters. Welcome to the National Seminar of Greentech 2020. We are broadcasting on online streaming with the theme Energizing Sustainability Through Smart Society. So for today's session, we're going to have three presentations. Two from Polytechnic of Sultan Azlan Shah and another one from Polytechnic of Tun Said Nasir. And all presenters will be given 30 minutes to present, including Q&A session. Without further ado, let's have the presentation from the first presenter, Puan Roshila binti Samsudin, with the title Analysis of Awkward and Repetitive Body Posture on Oil Palm Plantation Workers.
Assalamualaikum and good morning to everyone. My name is Roshila binti Samsudin. Today I want to present about analysis of awkward and repetitive body posture on oil palm plantation workers. My group member is Nur Hakimah binti Ahmad Subri from Polytechnic Cochin Sarawak, and me Roshila binti Samsudin from Polytechnic Sultan Azlan Shah, Nur Afifah binti Muhammad Ramzi from Polytechnic Sultan Azlan Shah, and Siti Syedatu Akmal binti Kamaruddin, also from Polytechnic Sultan Azlan Shah. Our study is about the long-term effect of ergonomic body posture on oil palm plantation workers who collect and transport palm oil manually by conduct an individual sample oil palm farmer at a small oil palm plantation. From the survey, the postural analysis of oil palm farmer fresh fruit bunch was performed using the rapid entire body assessment REBA evaluation technique to analyze awkward posture and repetitive art method to analyze repetitive movement. The ergonomic issue must be settled by redesign tools to enable neutral posture and mechanical exoskeleton innovation to achieve an optimum economic value in future palm oil industries in Malaysia. Oil palm cultivation is one of the largest in Malaysia for the agricultural sector and use a lot of manual labor to carry out activities. Manual material handling activities can expose workers to many health hazards and musculoskeletal disorder problems. The manual material handling activities that perform regularly and continuously are the main cause of ergonomic risk factor. For the hypothesis, we think working with incorrect posture cause ergonomic related health problems, and the biggest ergonomic problem is on the task of transporting fresh fruit bunch SPD from the ground to the truck. The study was conducted with an individual sample oil palm farmer at a small oil palm plantation located in Kampung Batu Hampar Dalam Beruas Perak, Malaysia. The respondents were asked to answer several questions to determine the workers' background, such as working experience, marital status, and labor instruction. After replying the surveys, the respondents were inquired to perform their working exercise as normal. Their work exercise were captured and recorded employing a video camera. Afterward, photograph and video records amid the perception were utilized to recognize ergonomic working stance of the oil palm rancher whereas performing their task. After collect the information, the ergonomic risk factor tools were decided. Ergonomic risk assessment tools we decide to use a rapid entire body assessment REBA. The aim is to identify and evaluate the risk postures of work-related entire body segments, which includes the neck, trunk, legs, arms, and wrist. Overall score for all body parts were calculated using REBA worksheet. Master and fourth score were added to the calculation, and then the final score for the both groups are summed to form the final action REBA score. The second tool we use is art method, repetitive. The assessment is split into 4 stages. Stage A is frequency and repetition of movements. Stage B is force. Stage C, awkward postures. And stage D is additional factors. For each stage, follow the flowchart and assessment guide to determine the level of risk for each risk factor. The level of risk are classified in the table 1. In table 1, G for green for low level of risk, A, amber, medium level of risk, R, red for high level of risk. Here result and analysis from the survey we done. Activity, manual handling tools by oil palm collectors and loaders. Size of palm oil plantation is 3 acres. Minimum weight of each fresh fruit bunch is 10 to 20 kg. Minimum total weight fresh fruit bunch per 3 acres is 3000 kg. Working hours is 8 hours per day. Break duration is 10 to 50 minutes per 2 to 3 hours. In picture 1 is the workers harvesting a ripe bunch with a sickle. For ergonomic risk factor, we know is awkward posture, musculoskeletal disorder, carpal tunnel syndrome, tendonitis, and tension neck syndrome. The second activity is the collector collect manually the fresh fruit bunch. Health effect is musculoskeletal disorders, carpal tunnel syndrome, tendonitis, tension neck syndrome, and frequent headache. The third activity is the loader then push the fully charged to lorry. Health effect is same with the picture 2, carpal tunnel syndrome, tendonitis, tension neck syndrome, and frequent headache. The last activity is the workers pick up a fresh fruit bunch to loading in lorry. Health effect is musculoskeletal disorders, carpal tunnel syndrome, tendonitis, tension neck syndrome, and frequent headache. We choose the last activity to get the rapid entire body assessment REBA result. First step, we need to analyze the neck, trunk, and leg analysis. First step is for neck position. We got the +3 for neck score. And step 2, to locate trunk position, we got +3 for trunk score. And leg score, we got +2. Using value from step 1, step 2, and step 3, here, and here, we got the +6 in table A for poster score A. And we got the +2 score for the load score because the weight of the fresh fruit bunch is over than 22 pounds. We add the value from the poster score A and load score to obtain the score A. And we mark it in table C, which is +8. Next is right arm and wrist analysis to get the score B. First, we got the score for upper arm position, which is +2, and lower arm position is +2, and wrist position is +1. Using value from the upper arm position, lower arm position, and wrist position, here, and here, we get the poster score B which is +2. And we got the coupling score is +1. To get the score B, we need to add poster score B and coupling score, and we get the score B, which is +3. After that, we mark it in table C for score B +3 and match with the score A in table C, which is +8, and we got the table C score, which is +8, and we plus with the activity score, which is +1, and the final rebus score is +9. In this case, we got +9 for rebus score. Refer to this table. The activity is high risk and we need to investigate and do the implement change. For the art and repetitive result, we choose this activity. The collector collect manually the fresh fruit bunch to loading wheelbarrow. For the repetitive result, for the A1 arm movement, for the right arms, we got 3 score, and the left arm, we got the 6 score. For the A2 repetition, the collector used the left and right arm for 11 to 20 times per minute, which is at 3 score. For the B force, collector pushing or forcing items together with some effort. Almost all the time is 80% or more, and we get the score is R8. For awkward poster result, for C1, head or neck poster, we got the 1 score, bend or twist part of the time. For the C2 back poster, we got the 2 score, bend forward, sideways or twist for more than half of the time. Additional factors for D1, breaks, 2 hours to less than 3 hours, which is score is 4. Work pace, speak to the workers about any difficulties they might have keeping up with the work. Sometimes difficult to keep up the work, score is 1. For the arm poster result is 2 for the right arm and 4 for the left arm. Wrist poster result, 1 score for the left arm and 2 for the right arm. Other factors is the collector sometimes complain about discomfort. For the right arm, 1 factor is present, which is 1 score, and left arm, 2 or more factors are present, which is 2 score. D4 is for duration. 4 hours to 8 hours is multiplier, duration is 1. For the hand finger grip result is for the left arm, we got 0 score, and for the right arm, we got the 1 score. And the final factor is the psychosocial factors. Incentive to skip breaks or finish early, monotonous work, and excessive work demands. After that, we add the A1 score, A2, B, C1, C2, C3, C4, C5, D1, D2, and D3 score value to get the task score for the left and right arm. For the left arm, we got the 32 score, and the right arm we got the 28 score for the task score. To get the exposure score, we need to multiply the task score and duration. So here for the left arm, we got the task score 32 and duration is 1. So we got the exposure score is 32. The right arm is 28, duration is 1. And then we got the exposure score is 28. So for the exposure level, for the left and right arm is at the level red. 22 or more, which is at the high level. So need to further investigation required urgent. For the conclusion, the REBA results show that loading fresh fruit bunch from ground to lorry are exposed to posterior economic issue. The body risk occur at the shoulder, upper back and neck area, while from art results show that repetitive activity loading fresh fruit bunch from ground to lorry exposed to repetitive economic issues. The repetitive art method shows a bending, awkward posture with enhanced movement with long working hour and short rest make a worker feel dizzy and have a risk at the shoulder, upper back and neck area. The work techniques and redesign economic tools must be applied so as to reduce the work-related musculoskeletal disorder (WMSD) risk. The economic issue above must be settled with proactive act to achieve an optimum economic value in future palm oil industries in Malaysia. Thank you.
Right, thank you, Puan Roshila, for a very interesting finding there. So now I'm going to open to the floor. Is there for any question for Q&A session? Maybe from the presenters, other presenters. Okay, I'll start with my question. The first one would be, could you please share with us what is the problem statement of this study before you that motivates you to do this research?
Okay, Assalamualaikum and good morning. Okay, the main problem here is we know that our oil palm plantation is the one of the largest activity in Malaysia in agriculture sector, and the use of manual labor, manual material handling activities. So our labor can expose to many health hazards about economic issue.
So this report has been cited in your research?
At introduction, I put it.
Okay, so it has been it should be written clearly in the problem statement that that point. Okay, thank you. And is there any possibility that other factors may influence the problem in the posture other than the workload?
Any factors?
Other factors other than the workload, the mood of the work. Is there any possibility that other factors may have come to play in this problem?
Yes. About their working hours.
And how many respondents involved in this research?
About 15%.
15 people.
Yeah.
So all of them are the plantation workers.
Yes.
That is it. Let's move on to the second presenter. Thank you, Puan Rushila. Let's move on to the second presenter, Puan Nur Rafidah binti Abdul Rahman, dengan tajuknya penentu keputusan pembelian produk hijau dalam kalangan pelajar TVET.
Kertas kajian penentu keputusan pembelian produk hijau dalam kalangan pelajar TVET PSAS bersama ahli kumpulan Fauzan binti Abdul Rahman dan Rosnayati binti Mansur. Berikut adalah kandungan pembentangan saya pada hari ini. Pendahuluan. Kerajaan Malaysia telah memperkenalkan pelbagai langkah dalam mempromosikan kelestarian alam sekitar. Amalan pembelian dan penggunaan produk boleh memberi kesan kepada kualiti alam sekitar. Bagi menyahut cabaran ini, Politeknik Malaysia telah melancarkan program Blueprint Polygreen Politeknik Malaysia. Dan di sini majoriti masyarakat Malaysia, terutamanya pengguna muda, prihatin terhadap isu persekitaran tetapi mereka tidak bersedia untuk mengubah tingkah laku pembelian mereka. Penyataan masalah. Masalah alam sekitar dan kesannya terhadap kesihatan manusia telah menjadi isu penting dalam kalangan ahli akademik, kerajaan dan organisasi yang berkaitan. Senario ini telah menyebabkan berlakunya perubahan permintaan dan tingkah laku pengguna. Kebimbangan dan kesedaran mengenai persekitaran ini telah mewujudkan penggunaan mesra alam yang disebut kepenggunaan hijau. Dalam isu ini, pengguna muda diberi perhatian kerana mereka adalah pengguna masa depan dan menjadi wakil kepada masyarakat. Lompang kajian. Berdasarkan kajian lepas, sehingga kini sejauh mana tingkah laku kelestarian penggunaan dan penentu kritikal pembelian produk hijau dalam kalangan pengguna muda perlu dikenal pasti. Terdapat dua objektif kajian yang digariskan. Yang pertama, mengkaji sejauh mana tingkah laku kelestarian penggunaan produk hijau dalam kalangan pengguna muda di Politeknik Sultan Azlan Shah. Yang kedua, menyiasat penentu tingkah laku kelestarian penggunaan produk hijau iaitu kesedaran persekitaran, pelabelan eko, pengiklanan hijau, harga dan sikap terhadap keputusan pembelian produk hijau. Antara kepentingan kajian ialah menyokong dasar yang telah dirancang oleh kerajaan, meningkatkan kesedaran amalan hijau di kalangan golongan muda serta membantu pihak JPPKK merencanakan kelestarian dalam kurikulum dan core kurikulum. Terdapat beberapa limitasi kajian iaitu saiz sampel yang kecil, kajian hanya dijalankan di PSAS dan ia hanya melibatkan sampel pelajar diploma akuntansi sahaja. Sorotan kajian. Keputusan pembelian produk hijau. Berdasarkan kajian lepas, antara faktor yang mempengaruhi keputusan pembelian produk hijau ialah kesedaran persekitaran, pelabelan eko, sikap pengiklanan hijau, harga, kepercayaan rakan sebaya dan kualiti. Kesedaran persekitaran adalah satu kesedaran yang mana berupaya membentuk kepercayaan dan sikap terhadap kelestarian persekitaran yang mempengaruhi tingkah laku pembelian. Pelabelan eko bertujuan membantu pengguna mengenal pasti ciri-ciri produk hijau sehingga berpotensi mengubah tingkah laku pembuatan keputusan yang lebih baik. Sikap positif terhadap perlindungan alam sekitar membuatkan pengguna cenderung mendapatkan produk hijau yang boleh mengurangkan kesan kepada alam sekitar. Terdapat pengguna yang mempunyai sikap alam sekitar yang positif tetapi masih menggunakan produk konvensional dan ini membuktikan sikap tidak membawa kepada niat untuk membeli produk hijau. Pengiklanan hijau didefinisikan sebagai tarikan yang cuba dilakukan untuk memenuhi kehendak dan aspirasi pengguna serta mampu meyakinkan dan meningkatkan imej atau jenama produk hijau. Daripada kajian, 70% daripada keputusan pembelian amat dipengaruhi oleh pengiklanan. Harga yang lebih tinggi memberi kesan kepada keputusan pembelian pengguna dan pengguna sanggup untuk membayar harga yang lebih tinggi untuk membeli makanan organik. Metodologi kajian. Untuk kajian ini, pendekatan kuantitatif digunakan dengan menggunakan kaedah tinjauan. Seramai 195 orang pelajar semester 2 hingga semester 6 diploma akuntansi telah dijadikan sebagai populasi untuk kajian ini dan kaedah persampilan yang digunakan adalah kaedah persampilan kluster. Instrumen yang digunakan untuk mengumpul data daripada para pelajar adalah menggunakan soal selidik dan dianalisis menggunakan PSAS version 23.0 dan analisis yang digunakan adalah analisis deskriptif dan inferensi. Dapatan kajian. Berdasarkan daripada analisis yang dibuat, didapati harga pengiklanan hijau, pelabelan eko dan juga kesedaran persekitaran mempunyai hubungan yang signifikan terhadap keputusan pembelian produk hijau berbanding dengan sikap yang tidak mempunyai hubungan yang signifikan terhadap keputusan pembelian produk hijau oleh pengguna muda. Daripada kajian ini dapat disimpulkan bahawa harga pengiklanan hijau, pelabelan eko dan kesedaran persekitaran mempunyai hubungan dengan keputusan pembelian hijau. Kajian ini juga menyokong kajian lepas bahawa sikap tidak mempunyai perkaitan dengan keputusan pembelian produk hijau. Antara cadangan yang dicadangkan oleh para pengkaji ialah mewujudkan silibus yang berkaitan kelestarian. Yang kedua, penerapan unsur kelestarian alam di dalam kurikulum dan kurikulum, dan kajian boleh membantu kerajaan untuk merealisasikan pelan pembangunan Blueprint Polygreen Politeknik Malaysia. Kajian ini boleh dilanjutkan lagi dengan mengkaji faktor lain yang mungkin mempengaruhi keputusan pembelian dan juga melaksanakan kajian merentasi sempadan antara Politeknik Malaysia bagi melihat perbandingan di antara politeknik-politeknik yang ada di Malaysia. Sekian, terima kasih.
Baik, terima kasih Puan Nur Rafidah Abdul Rahman. Minta onkan kamera untuk sesi soal jawab. Saya buka sesi ini kepada mana-mana presenters yang mungkin berminat untuk bertanyakan tentang tajuk pembentangan sebentar tadi. Okay, sekiranya tidak ada, saya ingin mulakan dengan soalan. Boleh Puan terangkan berkenaan dengan populasi kajian? Siapakah populasi bagi kajian ini?
Okay, bismillahirrahmanirrahim. Assalamualaikum dan salam sejahtera kepada Dr. Salwa selaku moderator dan juga kepada para pembentang sekalian. Okay, bagi kajian yang telah dijalankan ini, sampel yang kami ambil adalah pelajar-pelajar semester 2 sehingga semester 6 bagi program diploma akuntansi Politeknik Sultan Azlan Shah.
Ya. Maksudnya saya nak bertanyakan tentang populasi kajian, bukan saya.
Populasi adalah kesemua pelajar di diploma akuntansi daripada semester 2 sehingga semester 6. Itu adalah populasi kami.
Apakah rasional ataupun justifikasi di sebalik pemilihan populasi tersebut untuk kajian ini?
Okey, kami memilih populasi pelajar-pelajar diploma akuntansi kerana seperti yang kita tahu, pelajar-pelajar diploma akuntansi ini yang mana bila akhirnya mereka bergraduat, mereka akan menjadi pekerja-pekerja profesional sebagai accountant ataupun sebagai pembantu accountant dan sebagainya, yang mana di sini mereka akan bertindak sebagai salah seorang daripada pembuat keputusan. Jadi di sini dalam mereka membuat keputusan ini, mereka perlu juga mengambil kira kepada unsur-unsur kelestarian alam ini. Okay, dari segi penjimatan kos, dari segi pencemaran alam dan sebagainya. Jadi di sini kami merasakan pelajar-pelajar ini perlu dididik daripada sekarang berkenaan dengan kelestarian ini, supaya bila mereka bekerja nanti mereka boleh mengaplikasikan perkara yang mereka perolehi. Apa yang kami dapati, kalau dari segi subjek diploma accountancy sendiri, tiada orang kata secara langsung penerapan lestari dalam subjek-subjek tersebut. Tapi kalau secara tidak rasminya, memang pelajar-pelajar kami ni kami pergi bawa kepada untuk melibatkan diri dalam program CSR dan sebagainya. Tapi dari segi orang kata yang saya maksudkan tadi, secara rasminya maksudnya penerapan dalam silibus tu tak ada. Sebab itu di akhir tadi saya ada mencadangkan, pihak pengkaji ada mencadangkan supaya penerapan unsur-unsur kelestarian ini dimasukkan dalam secara langsung ke dalam silibus diploma accountancy ini.
Terima kasih. Soalan yang kedua berkaitan dengan persampilan kluster. Jadi saya lihat di situ persampilan ini telah dipilih daripada semester 2 dan semester 6. Boleh jelaskan macam mana persampilan kluster ini dibuat? Kerana kalau kita ikutkan, kalau populasi dia adalah pelajar accountancy, persampilan kluster ini perlu dibuat merentasi semua semester.
Okey. Merentasi semua semester. Okey, populasi semester 2 sehingga semester 6. Kami tidak mengambil pelajar semester 1 sebab pelajar semester 1 pada masa tu tak masuk lagi. Jadi sebab tu kami ambil semester 2 sehingga semester 6, dan kluster di situ kami membahagikan kepada kelas-kelas dat 2, dat 3, dat 4, dat 5. Kami mengambil persampilan kluster ini bagi memudahkan kami untuk pengesanan kepada responden, di mana setiap kluster-kluster ini ada PA dia. Jadi kalau ada maksudnya dari segi soal sidik tersebut, kami akan blast melalui PA, dan melalui PA akan hantar kepada akan forwardlah kepada anak-anak buah masing-masing.
Okey. Jadi saya rasa dari aspek penyelidikan, saya rasa kumpulan ini perlu membuat penelitian yang lebih berkaitan dengan persampilan ni. Sebab kalau kita lihat tadi, dia lebih kepada convenience sampling, bukannya cluster sampling. Tapi bagus, satu effort, satu usaha yang bagus, dan dapatan daripada itu pun boleh menghasilkan sesuatu contribution ataupun sumbangan kepada institusi kita. Okay, terima kasih Puan Nora Fida Abdul Rahman dan timnya.
Terima kasih.
We move on to the next presenter, Ms. Divya Darshini, all the way from Polytechnic Tun Syed Nasir. Let's have the presentation now.
Good day, ladies and gentlemen. I am Divya Darshini and a student from Polytechnic Tun Syed Nasir, Johor. Here to present my project about production of bottle from starch. My registration code for this Greentech conference is A22. There are also 4 other students apart from me that is participated in this conference, which are Mokana Sundari anak perempuan Maran, Ashwin Kumar anak lelaki Selvaratnam, Tiruvarsi anak perempuan Sukumaran, and Dr. Rosni binti Yusof. In today's modern period, we use plastic because it is very convenient as an everyday use, be it plastic bag or plastic bottle. It is cheaper and durable compared to other materials. Let's, let's just take water bottle as an example. We buy a simple plastic drinking bottle for around 1 ringgit and or so and only use it once and throw it away. It becomes a barren waste, and even with recycling ecosystem, it is still undestructible. Burning plastic is extremely bad because it produces poisonous fumes that cause carbon emission. Plastics are mostly made from petroleum, and its usage and disposal is ubiquitous every day. In order to solve these issues, bioplastic are introduced. It is degradable and known as green material, promising ingredient to replace petroleum-based plastic. This study focused on producing bioplastic from starch as alternative. There were three hand layup prepared, which are pure potato starch with glycerin and acetic acid, and also sago starch, glycerin and acetic acid. So, potato glycerin shows higher heat resistance and glass transition compared to pure potato starch, accounting from 60 degrees Celsius to 100 degrees Celsius and 40 degrees Celsius to 100 degrees Celsius respectively. Potato starch glycerin has more heat resistance ranging from 64 degrees Celsius to 87 degrees Celsius compared to sago starch glycerin ranging from 56 to 73 degrees Celsius. Therefore, bioplastic from starch-based product is a promising alternative to replace the existing conventional plastics such as high heat resistant to solve the environmental issues. Bioplastic product help to saving environmental by dismissing the usage of fossil and reduce the carbon emission. Bioplastics are biodegradable and always available around the globe, especially starch-based. Synthetic material usage causes many significant environmental problems. Major contributor to the environment pollution such as solid waste such as plastic bottle and other municipal waste. A plastic bottle takes up to 400 to 450 years to completely vanish from the surface of Earth. The excess landfilling caused to the environment as a result of non-compostable material in the environmental and endangering the marine life, encouraged in the discovering and developing bio-based alternatives in an attempt to minimize the aftermath effect of waste of plastic, such as the used plastic bottle. These unruly issues of solid waste. Bioplastic can be derived from starch such as polylactic acid. It is a starch. It is a starch extracted from corn, potato, sago, tapioca, PHP, which is also known as soy-based, and many more. Bioplastic based on starch have been studied in the field of engineering and material production, but fewer attempt to discover its full capability. Plenty of research which have discovered that blending starch with variety additive, for instance biopolymer, natural fibers such as pellet and synthetic fiber, shows improvisation in strength and durability. Hence, this project is aimed to discover and engineer a biodegradable bottle consisting of starch paste as the main ingredient of bioplastic. Additives such as glycerin is to make bioplastic more flexible. Acetic acid in the vinegar helps the starch to dissolve easily due to the addition of iron to mix together with the water as solvent. Biodegradation and biodegradation and bioplastic property. Biodegradability of a specific material or object is defined as capability of being decomposed by bacteria or other living organisms and avoiding pollution and landfilling with or without the help of oxygen. Absorption of water is the ability of water to have high resistance to water and last longer. Differential scanning calorimeter, DSC, is a thermoanalytic test to determine the crystallization, heat resistance, and glass transition of the bioplastic. These are the material and apparatus used. First is the main ingredient of the starch, bioplastic, potato peel, potato starch powder, and bioplastic formation. Beaker of 50 ml and 100 ml, measuring cylinder of 100 ml, glass rod to stir the solution, glycerin as the plasticizer for the solution that makes it make the bioplastic more flexible. Hot plate to heating the solution for specific temperature, silicone sheet for flattened surface of the solution, weighing scale, laboratory oven, and vinegar. Next is the methodology. Basically, there were three methods was used. First is the processing of the starch-based bioplastic. In here, the solution was tested using the water absorption method, degradation and composting method, and also differential scanning calorimeter DSC test. I would like to show the video about the processing of the starch-based bioplastic. absorption. Based on the table 1, pure potato starch has the highest value of average percentage of weight loss calculated, which is 75%. The potato starch with glycerin and acetic acid has the lowest water absorption, which is 24%. The average of the percentage of the weight loss for sago starch with glycerin and acetic acid is slightly higher than potato starch with glycerin and acetic acid, but gradually lower than pure potato starch at 34.50 degrees at 50%. Based on the graph obtained, the percentage of the water absorption for the pure starch is highest. This is because pure potato have higher tolerance to dissolve in water from 70 to 77% in 3 hours. The sample with addition of glycerin and acetic took much longer to absorb water. The presence of glycerin causes the potato starch 13% to 33% in 3 hours and sago starch 32% to 37% in 3 hours. To be more resistant, water resistant, naturally hygroscopic and highly hydrophilic show that increase in water absorption with respect to glycerol and starch. The function of adding glycerin as a plasticizer to help to flexibilize and promote the mobility and increase the mechanical property. Next is result analysis for degradation and composting. The biodegradation of the specimen was investigated in controlled environment. After weighing 3 specimens were buried under moist soil in room temperature. The samples whose initial masses were recorded and were weighed after burying weekly. The cause for degradation is due to the biological activity by enzymatic action, which directing a significant change in the form of chemical structure of the material. The weight loss measured in is a standard method for biodegradation of polymer is the weight loss measured which was calculated by the following represent in equation as shown in the report. The presence of adding glycerin and acetic acid help the potato starch easily degrade in soil and non-toxic to soil. The biodegradation ensure that the product is eco-friendly and that this product brings nothing but helping the marine life without endangering them. The next is result analysis for differential scanning calorimetry, DSC. And class transition evaluate DSC Q20 V24 11 Bill 24. As we already know, the DSC consists of 2 type sealed pan, which are sample pan and reference pan, and an empty sample pan. The aluminium coil compiled pan act as a radiation shield. The 2 pans are uniformly heated and cooled, whereas the difference of the heat flow within the 2 pans were monitored. This experiment is carried out in an isothermal temperature and also by altering the temperature at a constant rate, which is also known as temperature scanning. The DSC function as to measure the difference between the heat resistant and a reference pan that are exposed to the same temperature program of the given sample. After going through the machine, we have obtained the glass transition result, heat resistant, and also the crystallization of the specimen of 3 different specimens, which are the sago starch with glycerin and acetic acid, pure potato starch, and potato starch with glycerin and acetic acid. It was analyzed that the potato starch has more heat resistance, which is from 60 degrees to 100 degrees Celsius. compared to the sago starch because the temperature of the amorphous bioplastic made from potato starch and glycerin and acetic acid has increased molecular mobility compared to the pure potato starch, which result in significant change in the thermal properties. The glass transition temperature value is the temperature at which amorphous material change from hard to soft potato. Potato starch, glycerin and acetic acid as more heat resistant, which is at 64 degrees Celsius to 28 degrees Celsius to 87 compared to sago starch, glycerin and acetic acid, which is 56 to 73 degrees Celsius. This is because the presence of air bubble during the making of the sago specimen deflect the test analyzed. Sago starch absorbs more heat and compared to the potato starch. The analysis of comparing three samples, it is determined that potato starch with glycerin and acetic acid is the most compatible material to make the bioplastic. And here, in the graph shown, the glass transition occurs for the sago starch and glycerin and acetic acid. It shows that potato starch with glycerin is the most compatible material. The presence of the air bubble during the making of the specimen deflects the test. In conclusion, bioplastic materials that are able to degrade, which are important in producing product of bioplastic in the industry. The aim of this product was to determine the best suitable bio-based material to create a bioplastic bottle that is eco-friendly using just starch. From the result obtained from the data analysis, the differential scanning calorimeter of this starch-based material obtained shows that its crystallization and melting point and its glass transition. Here, it helps us to determine at which point the bioplastic actually change phases and which point the bioplastic is most suitable to use as the bioplastic bottle. The absorption of the water test shows that most suitable plastic with the lowest average percentage of absorptions are the production of bioplastic, which is the potato starch. But during the absorption of water, we also determined that using the PVA will also help in the production of bioplastic bottle, even with the using of potato starch with glycerin and acetic acid. The most promising starch-based bioplastic is potato starch with glycerin and acetic acid. Maybe because of the presence of amylose and cellulose in the potato starch makes it a better material to use as a starch-based bioplastic bottle. It also resists heat better than sago starch. The composting of this material in the soil shows that the definite material used as a bioplastic product able to degrade faster compared to the conventional bioplastic. Overall, the idea of this project will help to prevent the earth, ocean and environment from serious contamination and landfilling, and also by not burning this bioplastic from starch, it also helps to reduce the carbon emission. That will affect the diversity and health of both human and marine life. This material is made of what comes from our earth, and it can later on just as well end up in the soil without any risk for the nature and be the food for the marine life as well. If this project becomes successful, the landfill will become a serene habitat. The marine life that are affected from the bioplastic bottle will live peacefully and happily in their own habitat. There will be no more landfilling, there will be no more no more improper disposable of plastic bottle. The flora and fauna will be more happy, and the plastic bottle can be degradable and will forever be banished from the surface of Earth in a short amount of time. Bioplastic materials that are able to degrade naturally are important in producing products of bioplastic, essentially in packaging industries such as plastic bottles. Composting test shows that it degrades faster compared to non-degradable of conventional plastic. Help to prevent the earth, ocean, and also the environment from serious contamination and landfilling that will affect the diversity and health of both flora and fauna and humans and marine life. Thank you.
Okay, well done, Ms. Divya Darshini, for a very detailed presentation just now. And so once again, I open to all presenters if you have any questions to ask to Ms. Divya pertaining to her research. And I would like to ask everyone on the line to turn on the camera, because shortly after this session, we're going to have a photo session. All right, so please on camera, everyone. All right, so my question is, have you tried to come up with a prototype of a bottle, a plastic bottle, out of this substance?
Yes, actually, we did actually try to make a prototype to produce a real plastic bottle from using the material of from plastic bottle, glycerin, and acetic acid. But unfortunately, the project failed because of insufficient equipment for the molding method. Because normally plastic bottle is made from blow molding.
Okay, because from the aspects of water absorption, the potato starch still have 24%. Right, it is 24% of water absorption, so it may give some problem if you want to, come up with the plastic bottle. Is it?
Yes, after our absorptions of water test analysis, we were concluded that using PVA is better when we are making the real plastic bottle, because PVA acts as a substitute to be soluble compared to the starch material itself.
Okay, have you tested the degradation? The one that you said just now, the degradation process. Have you tested?
Yeah. I have tested the degradation using the PVA, but unfortunately, I didn't put it on the report because it was failed, because the molding method was not suitable for it.
Okay, right. So, anyone would like to add any questions? So for each test, how many samples?
There were about 3 trials made for each sample.
Okay. Right. So thank you so much. We have come to the end of the session, and I'd like to convey highest congratulations to everyone and each and every one of you for sharing a very insightful research. Very well done. And on behalf of Polytechnic Sultan Azlan Shah, I would like to convey my highest gratitude to everyone for being a part of this. So let's have a photo session now. Right, till we meet again, inshallah, someday, sometime in the future. Okay, thank you so much once again. Assalamu alaikum, and have a nice day ahead. Thank you.
Thank you.
Okay, thank you, Doktor.
Thank you.
Thank you, Doktor.